Hi there, we're going to have a look today at Kepler's third law, and specifically a hack of Kepler's third law, which I only came across last week. So let's have a look at this question. So the mean distance between Venus and the Sun is 0.72 astronomical units. Show that the period of orbit of Venus is around 220 days to two significant figures. So just in case you're not familiar with astronomical units, that's the average distance between the Earth and the Sun is 1 astronomical unit, and Venus is closer, so it's going to be less than 1. So, if I was to try this with my A-level physics class, the first thing I would have done would have been to get to this formula here, okay? The mathematical formula for Kepler's third law. T squared, the period squared, is equal to 4 pi squared over gm times r cubed. Or T squared is proportional to r cubed. Now, this is a lot more work than the hack, okay? So, you could always fast forward if you wanted to get straight to the hack, but this is the way that I would have worked it out, and you can see it's quite long-winded, okay? So, once you stuck the numbers in there, or most of the numbers, you can see I put in a big G, which is 6.67 times 10 to the minus 11. I've got the mass of the Sun there, approximately 1.99 times 10 to the 30. And then we've got the astronomical unit there in meters, okay? So that's quite a lot of work in itself. And then another step here to what the number is for t squared, and then square rooting that. And you can see there's quite a lot of steps here. So you get 1.93 times 10 to the 7 seconds. And of course the answer needs to be in years, okay? So converting that to to days. Days comes out to be 220 days to two significant figures. So that was quite a lot of work, wasn't it? Okay, so let's come across now a better way, a quicker way of getting to the answer. Okay, so this is something that astronomers would use. Okay, astronomers are not confined by SI units, is one way of putting it. Okay, but if we have a look here, lots of astronomers might put t squared equals r cubed. And that straight away seems a bit funny, right? So it's supposed to be t squared is equal to a constant times r cubed. But if t is in years and r is in astronomical units and the mass are in solar masses, then this works, okay? You can set t squared equal to r cubed. Now I'll just show you by way of an example a proof for the Earth. T squared over r cubed is a constant, as we've known up until this point. But if you put the numbers in for the Earth in terms of years and in terms of astronomical units, you get 1 squared over 1 cubed, which is indeed 1. So the constant is 1 in this situation. Okay, so let's just try and answer the problem now using this. Okay, so for Venus, then we've got t squared equals r cubed. And if we put the numbers in, or the number in, it's a lot easier, isn't it? Right? So t is equal to the square root of 0.72 cubed. And that comes out to be 0.61 years. And then converting that into days, it's around 220 days again to two significant figures. So you can see that's a heck of a lot easier than doing it in SI units and using the sort of A-level physics formula. So I hope you liked that little hack of Kepler's third law.